Hello good people, I'm going to talk about cis-trans isomerism in alkenes. Recall that alkenes contain a carbon-carbon double bond and that we cannot rotate around a double bond. This means that atoms that are attached to the carbons of the double bond are locked in place. Let me explore that a little bit more. To that end, I'm going to bring in two very similar compounds. Both of them contain two carbons, two chlorine atoms, and two hydrogen atoms. But these two compounds are not identical. They are isomers. Both of them contain two carbons with a double bond, so they are both definitely ethenes. Both of them have two chlorine atoms, so they are both dichloroethenes. In both cases, the chlorine atoms are attached to carbon 1 and carbon 2 respectively, so both of these are definitely 1,2-dichloroethenes. So far they seemingly have the same name. However, these are different compounds. And if we look at their melting points, we can see that the compound on top will melt at -80 degrees Celsius, while the compound at the bottom will melt at -50 degrees Celsius. They have different physical as well as chemical properties. This is because structurally they are different. When it comes to the compound at the top, the chlorine atoms, or if you like, the hydrogen atoms, are on the same side of the double bond. And so when identical atoms or groups of atoms are on the same side of a double bond, we call that a cis compound. So this is cis 1,2-dichloroethene. Down here, the identical atoms, so let's say chlorines or hydrogens, are on the opposing sides of the double bond. And when we have that, we talk about a trans compound. So in this case, we have trans 1,2-dichloroethene. Keep in mind that when we have a double bond, we cannot rotate around it. So the atoms are fairly locked into place. Let me look at another example. I'm going to bring in two isomers of butene. Both of these compounds have the same molecular formula, and in both cases the double bond exists between carbon 2 and 3, which means both of these are definitely two butenes. However, they are different compounds, and their melting points prove that. The compound on top melts at -139 degrees, while the compound at the bottom melts at 106 degrees. When it comes to the compound at the top, the identical atoms, let's say the hydrogens, are on the same side of the double bond. And so this is cis-2-butene. When it comes to the compound at the bottom, the identical atoms, once again we're going to pick the hydrogens, are on the opposing sides of the double bond, and so now we are talking about trans-2-butene. What would these two compounds, cis and trans-2-butene, look if I was to draw them using skeletal formulas? They would look something like this. When it comes to cis-2-butene, I'm trying to show that the CH3 groups, the methyl groups, are on the same side of the double bond. When it comes to trans-2-butene, I'm trying to show that the methyl groups, or the CH3 groups, are on the opposing sides of the double bond. So what would be a quick definition for cis and trans isomers? In case of cis isomers, we are talking about compounds where identical atoms or group of atoms are on the same side of the double bond. And when it comes to trans isomers, the identical atoms or groups of atoms are now on the opposing sides of a double bond. That is all for now, and I will see you on the flip side.